yours.
Cool. Hey, everyone. Thank you for joining us today. Before I begin, I just want to say, can we give a round of applause to the fantastic organizers of this event? Like, they've done a really amazing job bringing everyone together. Cool. All right, so just one question to everyone before I get started. Who here has played with virtual reality before? Any Daydream or Vive or? Cool, most of you. What about a desktop headset, like a Vive or an Oculus? All right, wow, still over half, nice. And who's tried to actually build something for virtual reality before? Cool, a few of you ahead of the curve. All right, so my name is Dale Knauss. I am the virtual and augmented reality lead for Presence. We build digital products. We're based out of San Francisco. We build everything from web and mobile products to virtual and augmented reality products. As the VR and AR lead, everything that we touch that goes into VR AR comes through me. Over the past year, we've built some really cool stuff. Discovery Channel, who's responsible for Shark Week and some big shows in the United States. We built their HTC Vive application. We worked with a really big financial services company to build a awesome demo to figure out what the future of VR for finance is going to look like. And we've been working on a really cool, really massively scaled project for a stealth startup that I can't really talk too much about, but if you follow me on Twitter, hopefully I'll have a cool announcement of that in a few months. So, like you said, I've kind of made the journey from a web and mobile developer into a virtual and augmented reality developer. And I'm not going to lie to you, it's a big learning curve. There's a lot of stuff you're going to have to learn about and overcome. But as I know most of you in this room are developers, and so you have a big edge up over anyone who's not. Hopefully, I have some things here that I'm going to share with you that will help you get the process going a little bit quicker. I've included a lot of links in my presentation to some really awesome resources that you can get started learning from today. And I have a lot of tips to just how to get started. So let's jump in. All right, so there's some similarities between being a VR developer and building any other type of application, but there's also a lot of differences. I want to go over a few of those. So first of all, I think this conference is really great because it brings together designers and developers as opposed to most conferences having separate for each. In virtual reality, it turns out that's a lot more important. Rather than kind of a throw it over the wall approach or even a collaborative approach, you're actually working hand in hand with designers, developers, artists, sound designers, and all sorts of other people to create really awesome content. That means you're not just having conversations, you're actually building tools and empowering everyone on your team to directly work on what you're building. This is a process that's already well known in games and movies where everyone kind of has a say, less well known on the web and in mobile. There's also a lot more unique specializations to focus on. You have your interaction developers, but you also have graphics programmers, technical artists, people who specialize in AI, people who specialize in networking. There's really a lot more specializations that you could go into, and a lot of people spend their whole careers just focusing on one particular area and really doing amazing things. You're also going to spend more time focusing on creating tools and systems. Like we'll talk about when we jump into Unity, there's a lot of power to create fantastic tools that enables the other members of your team to jump in and do the things and make the type of content and place it in the right ways that you'll want. And you're going to be using engines, not libraries. So because of the vast number of different things that go into making a virtual reality experience, it's not enough to just have some libraries that only the developers can understand. Engines, unless you're a AAA studio with years to invest, engines allow you to quickly get all the physics, all the rendering, all the audio, all of the various tools in one place that allow you to actually start building stuff pretty quickly. So with that being said, let's look at a few. On one side here, we have Unity and Unreal. These are the big game engines. Now, they're called game engines, but whether or not you're trying to build a game or a simulation or any other thing in virtual reality, it turns out these are pretty awesome choices. I actually started calling them extraordinary experience engines because we don't build games, but we rely heavily on tools like Unity and Unreal. On the other side, we have some web VR tools, A-Frame and React VR. As a web developer, formerly, I am really excited about these tools. WebVR is super cool. It's not quite ready for production yet, in my opinion. It's still like sticking something in a web view on mobile. But if you're interested and you want to see what the future is going to look like, I recommend giving them a go. So when we were getting started building virtual reality experiences for clients, we spent a lot of time researching the various engines. We spent a lot of time prototyping things. And really it came down to a choice between Unity and Unreal. Both of them allow you to build for any platform. They have a lot of tools, a big community. It's turned red. Let's see. All right, guess we're switching. Oh, did it start working again? Just after I took it off. That. Thanks. I was just complimenting him on how smoothly all the technical stuff was going at this conference. So like I was saying, we spent a lot of time trying to make up our minds between Unity and Unreal for our client projects. They're both awesome. Unity, you get to write in C# versus C++ with Unreal. Unity also has a bigger community. It has more resources available. And it's known for being able to get started with a little bit quicker. Some people will say Unreal has slightly better graphics quality, but unless you're a big AAA studio, you're probably not going to notice the difference. So with that being said, let's jump into Unity, an extraordinary experience engine. Now this is just going to be a really quick highlights tour of Unity. We don't have too much time, but I want to jump into some of the essentials and then give you a bunch of resources to keep going from here. So like I said, Unity actually will make native builds for pretty much any platform that you want to support, whether you're targeting mobile VR, desktop VR, or even augmented reality like the HoloLens or the Meta. Unity has direct relationships with all these companies and supports each of them pretty well. Now I will caveat this, just because you can build for anything doesn't mean you can build for everything. What I mean by this is the optimization requirements for something like Daydream or Cardboard are going to be dramatically different than your requirements on Oculus or Vive. The SDKs also, unfortunately, don't always play too well together. So, oops, connection lost. Oh, man. All right. But with a little bit of fighting, you can actually have one project where you can build for a lot of these platforms at one time, which is pretty useful when, at this point, no one really knows who's going to win the headset wars, and new platforms are coming out all the time. So this right here is pretty close to what you'll get when you open up Unity for the first time. I've moved around a few windows, but in general, this is where these are the various tools you're going to be spending most of your time with in Unity. Everyone understands these all right now, right? Totally, I don't need to go into any of this. All right, well, we will, don't worry. All right, so let's break it down. At the top here, you have a tools panel. This allows you to do things like configure how you're interacting with objects in your scene. It allows you to play and stop your experience. So if you want to test things, you can quickly go into play mode where you can actually see how things are going to look. And it has some other tools we won't actually go into. Next up, we have the game window. So this is really useful. This is actually what your main camera in your experience is going to look like. Now, with virtual reality, it can be a little bit deceptive. It will give you a flat 3D view of what you're looking at, but a lot of times it's not going to actually be totally what you're going to see in the headset. So this is really useful to iterate quickly, so you don't have to constantly be putting a headset on, taking a headset off, which you do spend a lot of time doing. But this allows you to quickly kind of get a feel for what it's going to look like when you put things in headset. Next up, we have the scene view. This is maybe the most important view you're going to be working in. From the scene view, you're able to manipulate the objects in your scene. So meaning if I have a few walls and I want to put them together to form a building, I'm going to use this to move the walls around, scale them up and down, and do everything else I need to actually create my scene or experience looking and feeling how I want it to. It also allows you to view things from any angle, which is super important. A lot of times things will look great from one angle, but then from every other angle will look terrible. So you want to kind of move your camera around, see what's going on. be able to get a feel for that pretty quickly. Next, we have the hierarchy window. This is kind of the list version of what you see in the scene view. It allows you to look through everything pretty quickly and get at exactly the component you want to work with. Now, one quick thing I'll note about this is a big rookie mistake that I see a lot of times is people don't pay much attention to naming and they don't pay much attention to placement. So the hierarchy kind of works like a folder system, which makes it really effective when you have hundreds or thousands of things in your scene and you want to find something pretty quickly. There's a search system, but you can actually use empty objects in the hierarchy to group and place things for easy finding later. So the more experience you get, the more time you'll spend naming the objects in your scene and placing them in the right place so they're easy for yourself and your team to find. And then finally, over here we have the inspector window. This is pretty cool and pretty powerful. So everything in Unity is what's called, almost everything in Unity is what's called a game object. That's essentially an empty container to put components on. I have here this camera selected. Now every game object has transform by default. If you know your linear algebra, I'm sure all of you do. A transform is a way of manipulating your objects through position, rotation, and scale, and it essentially dictates where your given object is in space and how it's scaled, how it's rotated. We'll go into that a little bit more. And then after that, you can place any components you want onto it. So this main camera here, which comes default, has a camera component on it, which actually just by putting this script built into Unity on the component, you're able to get all the capabilities you would with the camera. You can see there's a bunch of editable properties here, and it turns out it's really cool when we get into custom scripting. You'll see these are all kind of used for any script, but it lets you quickly change things directly from here without having to modify any code. Now, I mentioned earlier, designers and artists are going to be in here working on your, working in Unity right here along with you. So by having these properties editable in here as opposed to just in scripts, you're able to give people who aren't necessarily coders the power to manipulate what you've written for their specific needs. And then you're able to add more components directly in from here. So then we have a console, just like any other developer console. You'll see all your errors and logs and all that fun stuff in here. And then we have a project window, which is essentially just your file system. Makes it easy to sort, preview, and find the things you're looking for to put them in a scene. Then we have a whole bunch of other windows. I won't get into what all of them do, but essentially the cool thing about Unity is there's all sorts of tools built for all sorts of use cases. I don't even know half of the windows probably within Unity, but I use a lot of them on a regular basis. Even cooler, Unity exposes everything they use to create these tools to you as a developer. So let's say you want to create a custom tool to do things like control all of the animations in sequence in your experience. Well, there's actually a pretty cool one built into Unity as of the next release. But for now, we just had a project that we built where we built, using the same tools they used, we built a custom animation controller that we were able to just place as a normal window in Unity and use it just like we'd use one of the built-in ones pretty easily. I'll also note that, and actually we'll go back a slide for this, all of these windows are totally configurable. So you can control where they're placed on the scene or in the window, how big they are, how small they are. One of the big useful things that I see that a lot of beginners don't do is they just kind of leave the default configuration. But it turns out by just kind of spending a little bit of time configuring the way everything's set up for your particular task, you could actually be a lot more productive. For instance, if you want 4 scene views so you can see your experience from every angle that you're interested in, you could just set up 4 scene windows, have them side by side, and you'd always be able to see it without having to switch camera controls. All right, so quickly dive into scripting. What you'll see here is my awesome script. It inherits from a mono behavior, which is kind of the base class that everything inherits from in Unity, or almost everything. And I've included a bunch of public properties. Now, what's cool about this and why I included them is you'll see in the other picture we have a part of an inspector. So just by declaring something as public in my script, I now have it available in my inspector for anyone to use. Depending on what type it is, it will serialize to the correct type in the inspector. So you want to, for instance, you want to give a designer control of how fast a character moves in the experience. You set a speed, you set a public float of speed. You set a default number for it, and then you let the designer just change it to whatever they want and save it. That way when someone high up says, hey, we actually want this character to move twice as fast, you don't have to do anything. You just say, all right, well, change it. I've also included, every mono behavior has a whole bunch of lifecycle methods. I've included a bunch of them here. I won't go into them, but there they are. And then building for virtual reality, super easy. There's one checkbox and then a little drop down that you choose which platforms you're interested in. Though, however, that's just kind of the basic functionality. Each of the headset makers provides a custom SDK for a bunch more functionality. So I've included links here. I'm actually going to be posting all of this presentation on Twitter and also have a link at the end of this presentation. There's going to be a bunch of links to cool resources. So don't feel like you have to capture them all now. You'll be able to go back and get them afterwards. All right, cool. So you're going to need to know a lot of things as a Unity developer. So let's go into a few of them. First of all, you're going to need to know the Unity fundamentals. Unless you're already an expert from the first set of slides, which I'm sure you all are, you're going to need to know a bunch of things. Obviously, the basic scripting, mono behavior API, and lifecycle stuff, what each Unity window does and how it works, just being familiar with all of them, how to use the systems that interest you. So for instance, there's all sorts of cool physics interactions you can use. There's all sorts of animation work. There's particle effects that make things glow or make cool things happen when you click a button or you use your laser pointer. There's a pretty comprehensive UI system. There's networking stuff. There's all sorts of cool systems that you might be interested in. So knowing a little bit about what's available to you and how to use them is pretty cool. And then some basics around debugging and profiling, the usual development stuff. So I've included a bunch of great links here to get started with. Recommend going through a few of them as your kind of first step into Unity. Of course, you're going to finish them, and like most people do, try to actually build something and realize, oh shoot, actually, I really still have no idea what I'm doing. So let's go into some more detailed stuff to get you going. So if you don't already know C#, it's your normal object-oriented language. Unity actually has other few languages that you can use by default, including something that kind of looks like JavaScript, but the majority of the community uses C#. And even though I'm an actual lover of JavaScript, I also use C# just because it's really the Unity way of doing things. You're going to want to know object-oriented programming. I'm sure all of you do already. You want to know about coroutines. Entity component systems is something you'll see come up all the time in VR development and game development in general. And then object pooling, just another pattern that you'll see, performance optimization pattern that you'll see a lot. And so again, a few great links here to get going with there. All right, so 3D graphics. Now, 3D graphics is an amazing, wonderful, and horribly complex field, and there's an infinite number of things to learn. Just a few basics to get started with. You're going to want to know about the 3D coordinate system, if you're not, or otherwise the Cartesian coordinate system. You're going to want to know about textures, vertices, faces, polygons, meshes. This is everything that goes into actually constructing a 3D object. You're also going to want to know about shaders. Now, a word of caution about shaders. They're pretty much one part math, one part pixie dust, and one part black magic. There's some pretty complicated bits of code written in a special language that allow you to do all sorts of cool things on a pixel by pixel or piece of geometry by piece of geometry level to allow you to do all sorts of amazing stuff. They're also horribly complex, and your average developer, even VR developer, does little more than maybe potentially edit them. There's some group of geniuses that actually can do wonderful things with shaders. If you're ever bored, there's a site called shadertoy.com that has some insanely amazing things you can do using just math. So it's pretty cool. And then 3D modeling. You probably won't do 3D modeling as a developer, but knowing the basics and being able to at least put together a few basic things will really take you a far way. Blender is a free 3D modeling tool that a lot of people use to get started with. Maya is kind of the more pro tool. There's also a few others, but those are a few good ones to get started with. And again, a few links, especially want to call out to the cat-like coding tutorials, which are some really fantastic 3D graphics tutorials that use Unity to let you build all sorts of really cool stuff. They're a bit complex, so I recommend a little bit later down your journey going into that, but really cool. You're also going to need to know some 3D math. Before I started doing VR development, I'll admit my last math was in college and I'd forgotten all of it. So if you're like me, you're gonna need to go back and study your trig again. And then as a precursor to learning linear algebra. Pretty much everything going on in 3D graphics relies heavily on linear algebra. Understanding vectors and how they work, understanding matrices, understanding quaternions will really take you a far way once you want to get past just the basics. And again, a few cool links. Particularly Khan Academy has some really fantastic math tutorials that I'd recommend going through. All right. So next thing you're going to need to know is what's out there already. So the mistake I see a lot of people make is they get into virtual reality, they try a few things, they start building stuff, and they don't spend enough time actually playing in the headset. So the cool thing about virtual reality is it's so new that no one knows all of the cool stuff you can do with it yet. People are constantly experimenting, trying new things, trying different ways that you can actually let people move around. How do I interact with things in my experience? How do I use the controllers effectively? What does my UI look like? No one really knows yet. So playing with a whole bunch of different things allows you to get a good understanding of what other people are trying and give you ideas about stuff you could try in your own experiences. These are a few of my favorites for a bunch of different platforms. I won't list them all, but they're all fantastic. Depending on what you have, go through them. Play with everything. Try demos, try full experiences. You're going to get a lot of cool inspiration and stuff. And what's cooler, VR is such a small field. If you're interested in how something works in one of these things, chances are you could find the person on Twitter and ask them directly. And people are super cool about that. But you don't actually need to know really any of this stuff to get started. If you're like me, I want immediate gratification. And I want to start building stuff as soon as I know about it. So here's a few tips on how to start building stuff today. First of all, start small. Common mistake I see is people start off thinking they're going to build they're going to build the metaverse. They're going to build this vast virtual world where everything is in perfect graphical fidelity, highly networked and flawless. You're going to burn yourself out doing that. Start small, prototype. A lot of cool stuff by even the best virtual reality developers is still just prototypes that they put together in a weekend to try some cool new concept. White box everything. So this is a pretty common technique. It turns out that the interactions for controlling these three colorful cubes, all the development that goes into them is actually pretty much identical to the development that goes into building this beautiful, crazy dystopian world we see on the other side here. You can actually build out your whole experience or your whole game without having any 3D models. I just put those 3 cubes in there in 2 seconds, and I could build all the interactions exactly how I'd have them with 3D models. And when I'm ready and I have them, I could just plug in those and it's going to work exactly the same. So when you're getting started, don't worry so much about not having really great assets, because you don't need them. You could do everything you need pretty straightforward without them. Next up, use awesome open source libraries. So Unity has this weird culture of the Unity Asset Store allows you to buy all sorts of libraries and assets. Unfortunately, you have to pay for a lot of them, which, as coming from the world of open source, took me a long time to get used to. I now do, because there's some amazing work being done, and it saves us a lot of times on projects. But I really still love open source. Now, fortunately, there's a few open source libraries that are pretty much head and toes above everything else for VR development. VRTK is probably the most prominent of these. It's a fantastic library for, so it's definitely Oculus and Vive. I think they're adding Gear and Daydream support. I'm not sure where the status of them is yet. But it lets you do everything you need, including movement, laser pointers, locomotion, interaction systems, and all these really hard problems they've solved in the library that you could just include and get going with right now. Likewise, Newton VR has a really complex physics interaction system. They actually turn out to work pretty well together, but I'd recommend if you're getting started with a VR project for any of the platforms that VRTK supports, you're going to want to put it in there, unless you have super special requirements or you're on a big team where you can afford to develop everything they have themselves. Now, you are going to want to use pre-built assets and libraries eventually. So there's a lot of great free ones out there. That cool futuristic picture I showed off earlier was just some free 3D models I got from the Unity Asset Store that I could use in any experience. They have all sorts of great stuff. Sketchfab and TurboSquid, a bunch of great 3D models you can either buy or just get. Freesound.org, so you need sound effects or background audio for your experience, get it there or in the asset store. And there's a bunch of others like this. You don't have to spend any money. You could often get some really cool free assets. Or make really good friends with a 3D artist. That's another good approach there. You're also going to want to find great community for help. So there's a few great Slack groups, which unfortunately I don't have links to, that have helped me immeasurably as I've kind of made my progression. I recommend looking for VR devs or the VRTK Slack and asking questions there. Fantastic resources. The Unity 3D subreddit is great, and the Unity forums is also pretty good. Cool. So I want to kind of conclude with the 7 habits of a highly effective VR developer. Habit number 1, engage all the senses. So coming from the world of web and mobile, we're used to just a few things. We're used to the visual, and maybe if you have a video, you have some sound or something. But in general, we're just thinking about the visual aspect of it. In VR, we have so much more possibilities. When we pick something up, we want it to have some tactile feel to it. We want to actually know we're feeling it. When I put it down, I want to hear that satisfying clunk of it being put on the ground or on the podium. So I think a lot of people make the mistake of seeing VR as a visual medium because they see the big bulky headset. But just as important to a really awesome VR experience is, what does it sound like? Is the sound actually using spatial audio that makes me feel like I'm actually in a room and that the sound waves are bouncing all about? Of course, what does it look like? Is the lighting appropriate? But also, what does it feel like? For the Vive and the Oculus, you're able to get haptics, and even cooler haptic solutions are coming every day. So in the not too distant future, when you reach out to pick something up, it'll actually feel like the thing you're picking up. There's even work being done with taste and smell. Now, I don't know if that will ever become a thing, but in general, in your experiences, the more realistic and the more you can have match the expectations of the user, the more immersive and the greater states of presence you'll be able to add to the user. So you want to focus in your experiences on engaging as many senses as possible. Next up, build tools that empower your team. I showed you some of the tools that Unity has built to empower people to work quicker, but chances are your project is going to have some really custom needs that you're going to need to account for. One of the greatest things you can do to get your project going quicker is build tools directly in the Unity editor or otherwise that enable you to do that. Pretty much every project we work on, we identify at least 1 or 2 tools that will make it easier for instance, the 3D artists to bring in their work, or us as developers to just move a little bit quicker. So that's a big productivity gain. Next up, optimize early and often. Virtual reality has some pretty high requirements right now in terms of targeted frame rates in order to not make people sick. So you're aiming for about 90 frames per second on like desktop VR and 60 frames per second on mobile VR. Now, unfortunately, it also has really high rendering costs since it's rendering 2 times in most systems. So you're going to want to optimize early and often. This isn't something that you can just put off for later down the line and solve it later. If you're not focusing on making sure that all of your art assets are low enough on poly count and are optimized enough for your experience, if you're not focused that your scripts aren't doing all sorts of crazy stuff from early on, you're going to get to the end of your project and realize that you just can't ship. You don't have anything you can use yet. So using the profiler early, working with artists if you have them to make sure they're optimizing the poly count of their models. Good story there. On a recent project, we were working with a 3D artist who had spent a lot of time doing 3D modeling for film, where they don't care because they're not doing real-time rendering. So they gave us these beautiful models, but they were massively too large and complex for the experience. We ended up having to cut them by, just dramatically reduce the amount of polygons in the models to go from anywhere near a reasonable frame rate. So making sure you're working with your artists and internally focusing on optimization early is super important. Having said that, taking risks and prototyping ideas is critical at this stage in VR development. The fact is, nobody knows what works yet. Nobody knows whether your idea is going to be cool or not, and just drawing it on a piece of paper isn't enough. I've had a lot of times where artists will give me this beautiful 3D sketch, or not 3D, 2D sketch of how this feature should work inside of VR. It'll just be amazing and all shiny and fancy, and then I try to implement it and it falls flat. The only way to know whether or not something is gonna work is to actually try it in VR. That means that you're gonna be spending more time than you might be used to prototyping stuff and throwing out a lot of the stuff you're prototyping. So, having said that, don't be afraid to take risks. Don't be afraid that just because you haven't seen it in another VR experience doesn't mean it's good. There's all sorts of opportunities to really create fantastic stuff that will be used by everyone going forward, but you can only do that by taking risks and trying really cool things. So this is the only exception to the optimize early. When you're focusing on prototyping, obviously no optimization necessary. Spend more time in VR. Like I said, you should be spending as much time as possible trying other people's experiences and as much time as possible in your own experience. It's amazing to me seeing some people who aren't familiar with this type of workflow trying to work on a VR project only to discover that since they've spent the whole time viewing everything in a 2D way, when they put on the headset, after maybe even months of development, they're surprised by what they see. Why is that? VR, as soon as you put on the headset, it's a radically different, everything's gonna look and feel radically different than it does in a 2D plane, like a monitor. So you should be spending as much time as possible, whether you're a developer or a designer or anyone on a VR project, actually in the headset, trying things and making sure that everything feels exactly how you want it to. Next up, get help from the VR community. Small community at this point, everyone's super friendly. I've contacted many of my heroes, essentially people who are building really great virtual reality stuff, and everyone is super psyched to help out, to give advice, even to point you in the right direction if you're having problems with a bit of code, and you will have a lot of problems with bits of code. So don't be afraid to reach out to people in the VR community. Don't be afraid to get involved, to go to conferences, and to find groups where you can ask questions and get help. And then finally, have fun and build what excites you. Virtual reality is awesome. In case you couldn't tell, I'm truly in love with it. I find something new and cool and exciting every day. There's artists that are, I think, gonna change what we consider modern art in the next 5 to 10 years that are doing spectacular, wonderful things that you can't even imagine. Just playing around, trying things, making full use of the vast amount of colors available, the way that we can actually transport people to worlds that don't exist or to impossible worlds where the laws of physics don't behave. Just by playing around with scale, you could feel what it's like to be a giant in a room or an ant in the same room, just by scaling up how tall your camera is. You can really do whatever you want in virtual reality, but make it feel real. And that's super exciting because we've never really had that opportunity before. So getting into virtual reality means, should be something that excites you, and you should be free to have fun and to play around and to try cool new things. So if you ever feel like you're doing stuff and you're not having fun, maybe take a step back and question what you're doing and how you can do it a little bit better. So that's it for my slides. I think I might have finished a little bit early. Like I said, all the slides are available at presencepg.com/ideas/MCE2017. I did finish early. Again, everything I said here, just really quickly, is also applicable to AR. I know I didn't mention augmented reality at all in this talk, but whether you're playing with the HoloLens or Tango or anything like that, that's also totally supported by Unity. You're gonna need to know all the same things, all the same topics are available to you. So, and it's also a really cool and an exciting field, so you can't really waste your learning on either of them. Cool,
Okay.
With that.
Thanks, Dale. Any questions from the audience?
Hi, my name is Daniel, and I'm from Handcrafted Mobile. We actually were doing the same, so we were past mobile developers, but I'm also an enthusiast of VR. Before that, it was the stereoscopic thing and so on. My question is regarding the prototyping and designers. So how do you deal? You said that your designers work also in Unity, that they are like working with the same tool. So how do you deal with providing like how do they work with the Unity and in terms of control version? Like for example, do they commit them, create scenes, or do they pass that by themselves, or do developers always need to be with them? And my second question is a little bit on that. How do you deal with scenes, like working together with with the multiple developers? How do you deal with merging scenes when few developers need to work on the same scene and the same objects?
Yeah, great questions. So first of all, we actually work with a lot of different design and art agencies. So we don't have in-house teams, but so it turns out a lot of people aren't used to working with the workflow of actually getting designers into Unity. So a lot of times the first thing we do when we'll kick off a new project is actually sit down with designers who are interested. There's sometimes some resistance, but the designers who are interested, show them Unity and start working with them right away on a workflow that works for both groups. So my general approach is depending on the project, most of the time we'll use GitHub, sometimes Git. It's not always best for every project, but I'll actually sit down, explain the fundamentals of Git, and have a workflow where every single change they do requires a separate commit. Now, it's a little bit overkill, but particularly for people who are new with Git, it's kind of essential to make sure nothing breaks. But we do actually getting them committing directly to Git, usually using a source tree or another GUI. And after a while of hand-holding and just kind of sitting with them and kind of explaining the basics and getting them comfortable, a lot of the designers we work with actually find that they prefer it over having to manually ask for each change that they want. In regard to merging scenes, so this is actually a big annoyance with Unity. Merging is sometimes a nightmare. There's a few things that we do to make it less of a nightmare. So this is for anyone, I don't know if there's some non-developers in here, but we have everything checked into version control, so it's always the latest state. We could always revert. However, because of the way Unity serializes your scene data, you can't always, merging when two different people have worked on the same scene can be a nightmare. There's a few things you can do. You can turn on text serialization as opposed to binary serialization. Makes it a little bit easier to see what changes have been made. There's some degree of trying to not work on the same scene at the same time. So a scene in Unity is essentially one set of work that you can, so think of it like a scene in a movie. So each set is a little bit different. So if possible, we try to not let people work in the same scene. There's also relying heavily on prefabs. Prefabs are kind of groups of functionality that you can operate separately from the scene they're in and then use them multiple times in different scenes. And that makes it a little bit easier. So if you're just working on a prefab, you're not actually altering the scene itself. And then some just trial error, making sure people are there for merges so you're not stepping on each other's toes. But unfortunately, it's always going to be a little bit of a pain.
Okay, I've got another question if I can. Have you tried, the Unity, I think, tries to provide some kind of tool for that. I'm not sure the name, but it was something kind of Merge Magic or something like that. For merging scenes they called it in a semantically proper way or something like that. So have you tried that or not?
No, never tried it.
Okay.
I'll have to check it out. Thanks.
Okay, thanks. Okay.
Any other questions? Yes.
Hello, thank you for your presentation, and I got a question about the financial aspect. VR is fun, exciting, but it's still a pretty niche area, and creating the good VR product is a ton of work. Do you got any tips how to make a project viable?
Yeah, sure. So since we're a consultancy, we're actually working with companies who are exploring VR for their own purposes, so that makes it a little bit easier from our perspective. You're right, the financials aren't necessarily there yet to be able to create a product and sell it and actually like really make loads of money from it. We see it kind of more as an investment into the future rather than necessarily something that's going to make you a lot of money today. So a lot of the companies we work with see VR, they see the potential of it and where it's going, and they know that just like when the internet came around, just like when mobile became big, if they're not early into the space, other people will be. So by actually starting to explore and build things now and build that expertise internally, once VR gets to the stage that we're seeing coming down a few years down the line, they're going to be ready for that and be ahead of their competition who's going to have to start building from scratch. But yeah, like I said, if you're just wanting to build a game or an experience, unless you're a single indie dev that's willing to do everything yourself, you're going to potentially struggle. But once 2 years down the line, when VR is everywhere and immersive and you've built up all that experience, you're going to be sitting pretty. So it's a little bit, do you invest now or do you wait for later?
Yeah, I hope that's how it will go.
Me too.
Okay, do we have more questions? There is a chance for last one.
Hi, can you maybe tell a little bit more about the research that's been done right now to, let's say, conquer the problem of people getting sick when using VR, head spinning, etc., those side effects?
Yeah, sure. So for anyone who doesn't know, early VR had a lot of problems with making a lot of people very sick. It turns out, well, okay, so there's a few things. Sometimes we want to do cool stuff in VR that would probably actually make us sick if we were moving in crazy ways in real life. So we're kind of dealing with something where if we're trying to replicate reality and something in reality would make you feel sick, it's also going to make you feel sick in the headset. And then there's another class of problems, things like movement, how quickly you move from place to place and what's the motion of that movement and how much that will actually, if you move too fast or unsteadily or like your roller coaster type of thing, you actually could make a certain percentage of people pretty sick. A lot of the tools that people are using to fight that are, for instance, a lot of VR experiences you'll see, we call it like coin toss or Bezier curve locomotion, where instead of a constant motion from one place to another, it's kind of like a teleportation. So I'd say, I want to go over there, and it just instantly blinks you over there, eliminating the problem of that type of movement. But it does still require a lot of just play testing and a lot of trying different things and making amongst a lot of different people, because some people get sick from things and some people don't. And so it's important that you, A, look at what other people are doing to try to combat that in terms of how they're letting you move, and then B, do a lot of user research where you're actually trying out different things and seeing what works and what doesn't. There's a lot of techniques you can find also, but I wouldn't recommend, like, there's the techniques at this point, people will say, well, you can't let people just move forward by holding forward the joystick because it will make people sick. And then someone tries it and figures out a way to do it well, and all of a sudden it works. So I don't want to really recommend any of those ways, because until you've actually tried some of the ideas yourself, you might actually be limiting yourself in ways you don't need to.
Okay. One last question. Just
Cool.
wait. Yeah.
So he asked
Can
what
you
platform.
repeat the question?
Yeah, I was about to.
Yep.
Yeah, he asked what platform would I recommend getting to start experimenting with. I think that the HTC Vive would be the perfect platform at this point, because it points not just to where we are, but where we're going. It allows full room scale, meaning that I could, just by setting up my 2 lighthouses, I could move anywhere in this space and I'm perfectly tracked. The controllers are pretty good. I think the Oculus Touch controllers are a little bit better. And just overall, it's a pretty powerful system and a pretty modifiable system. So I would, if at all possible, I would go with the Vive. If you're, for whatever reason, limited to mobile, I really like Daydream. So depending on your budget and what you're trying to do, that might be a better fit. Though I think we're going to get to a point where everything relies on 2 controllers or just tracked hands, and everything relies on fully room scale, as opposed to your mobile headsets right now, which are not tracked and only have 3 degrees of freedom as opposed to 6. So Vive or Oculus, best. Daydream, next best.
Okay. Thank you, Dale. for a very good presentation for explaining how to start with VR. I have one announcement. At 3 p.m. there was a talk cancelled because Etienne Caron from Canada, he couldn't come. But we managed to work out a solution where he will do this talk remotely. So at stage 3, his talk is back. So you're invited. This is talk about AR and Tango. So you will be able to take part in the talk anyway. And Etienne will be there to answer your questions as well remotely. So go and check out this talk at 3 p.m. Thank you once again, Dale. Give a round of applause.
Just one last thing. If anyone has questions, also feel free to contact me on Twitter or shoot me an email. I'm happy to answer any more questions that come up.